Welcome to solverfy.
Okay, so I have put on here two pictures from the figure, so you will know why I did this. So let me begin with the first picture now. The question says that ammeter A1 reads 10 amperes, right? So let me mark here current I1. This is current I1, okay, and I1 is equal to 10 meters, 10 amperes. Okay, right now, and the batteries have no appreciable internals. Okay, so what is the resistance R? So we don't know R. So let us mark the currents here for determining the current readings in each ammeter. So let us consider this to be I2. The direction doesn't matter as long as you make them right at the end. This along R4, let us suppose, and as I2 goes here, so let us consider I2 gets divided as here and here, right? Here I1 got divided into I2 and I4, and here I2 got divided into these two, and let me call this as I5 because this is measured by the fifth. This is I5 and this is actually measured by A3, so I3. Okay, now if you want to use Kirchhoff's law, so the easy way is to always begin with the positive side of the battery like this. Here this is the first loop, and in this case the positive side is like this. So this is the loop. In this case, this is the loop. Always begin with the positive side of the battery, so that makes it easier. So for the first loop, write the battery first, that is 200. Now where are the drops? So the first drop is across R, right? So I1 into R. So I1 R. Okay. Now is there any other potential drop across the circuit? No. So this is the first equation for the first loop, and this gives us the value for R, which is equal to 200 divided by 10, that is 20 ohms. Okay, so let's move on to the second loop. Now the second loop, first again as previous, we write the potential 160, right? Now where is this potential dropped? So as you move here, so the first potential is dropped here, and the current across this is what, I2. So, and this is in the negative direction of the loop. So let me write it here as minus 40 I2, right? And anywhere else there is a drop in the voltage? No, there is no resistance here, so nowhere there is drop. So this gives us the value of I2. Well, we are getting at least one values for every loop. That is good. That makes it easier to calculate at the end. So I2 equal to minus 4 ohm. So this actually means that the direction that we supposed of I2 is actually the opposite, right? So actually I2 flows this way, right? This way. The arrows would have been the other way. Okay, we can later. That is what I wanted in the second figure. Okay, so let us continue with the loops, writing the equation for the loops. For the third loop, again the voltage there is 160, right? So this is equal to, now where are the potential drops? So there is no drops here. Okay, here there is a drop of for the 20 ohm resistor, and the current is I5. So the drop is, okay, it is in the loop, it is in the direction of the current is in the direction of the loop. So plus 20 I5, so 20 I5, right? So this gives me I5 equals to 160 by 20, that is 8 ampere. Okay, I forgot to write the unit here, that is ampere. Yeah. Okay, so we have already utilized all three loops. Now what we can utilize else, and we have only calculated this was given, this current was given, this I2 we calculated, and I5 we calculated. We still need to find I3 and I4. So for that we can use the relation between the currents. If you see the figure, we have created I2 and I4 such that I1 gets separated into I2 and I4. So I2 plus I4 should be I1. So if you plug the values of I1 and I2 here, so 10 equals to minus 4 times I4. So I4 should be 14 amperes, right? Also, the other relation is that I2 divides into I3 and I5. So we can write I2 equals to I3 plus I5. Right now, of these we know I2 and I5, we don't know I3. So minus 4 equals to I3 plus 8. So this gives me I3 equals to minus 12 amperes, right? So we are found I4 and I3 as well. So we have found all the remaining currents. So if you want, then you can now draw the currents in their actual direction. So I1 is positive, so this is as it is 10 amperes, right? Now I2 is negative, so actually this is this way, and the magnitude is 4 amperes, and I4 is in the same direction, so this is again 14. Now if you look at the figure, this matches very well. See, look here, so 10 goes from here, 4 goes from here, they mix up and become 14. Isn't it great to see? Yeah. Now what is I3? Now I3 is minus, so it is in the opposite direction, so it is this way. So I3 is this way, and that is 12 amperes, right? And what about I5? So I5, it is 8 amperes positive, so our direction of current was correct. So this is 8 amperes, so that is what is read by the ammeter A5, right? So we are done with the solution of this question. Thank you for watching.